Hello, good morning. Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today, in this video, we are discussing about one more important advanced mathematical methods of physics question. Already, we are discussing in advanced mathematical methods of physics according to CSIR syllabus. What is the advanced mathematical methods of physics? Once you have to see, the first topic is Green's function. The first topic is which function it is? Green's function. The first topic is Green's function. The second topic is partial differential equations. In the partial differential equations, we discussed the three equations. The first one is the Laplace equation. The second one is the heat equation. The third one is a wave equation. Three equations we have under the partial differential equation. The third topic is elements of computational techniques. Elements of computational techniques. Elements of computational techniques. In element of computational techniques, which one we have to see? Elements of computational techniques. The first topic itself, roots of function. The first topic is roots of function. From the roots of function, we discussed one question, that is the Newton-Raphson method we discussed. The second topic is interpolation and extrapolation. Interpolation and extrapolation. This is the second topic, interpolation and extrapolation. The third topic is, the first topic is roots of function. The second topic is interpolation and extrapolation. The third topic is, so what is the third topic? Numerical integration. Numerical integration. In the numerical integration, we have two methods. One is a trapezoidal rule. One is a trapezoidal rule. Another one is Simpson's rule is there. Simpson's rule. Another one is Simpson's rule. Trapezoidal rule and Simpson's rule. Now you have to see from the advanced mathematical methods of physics, Green's function we discussed, advanced mathematical methods of physics, right? So Green's function we discussed the Green's function, correct? We discussed the Green function. In the partial wave differential equation, from the Laplace equation we discussed one question. From the heat equation we discussed one question. From the wave equation also we discussed one question. From the elements of a computational techniques, the first topic we discussed about the roots of function. The second topic in the previous classes we discussed about the Newton's forward difference formula. And the third topic is numerical integration. In the numerical integration, two topics are there. That is the trapezoidal rule and Simpson's rule is there. One more topic is there, that is the first order differential equation solution by using the Runge-Kutta. Fourth order is there. So maybe in tomorrow's class we have to discuss that one. So this is the advanced mathematical methods of physics topics. Once you have to see. Today we have to discuss about the Simpson's rule. When this question came, CSIR June 2018, they are asked this question. CSIR June 2018, once you have to see the fractional error in estimating the integral. Suppose you have to see what is that integral. Integral 0 to 1, integral 0 to 1 x dx. Integral 0 to 1 x dx using Simpson's 1/3 rule, using a step size 0.1 is nearest to. So they have want to give first what is the fractional error. What is the fractional error you have to measure. Fractional error we need to calculate. Fractional error is equal to, so variation of integral, approximated error minus approximated integral minus true integral. So integral of the true integral, so we into what is that fractional error if you have to take so if percentage if you want to write, percentage if you want to write, otherwise this is the formula for the fractional error. So the variation of the integral is divided by the true integral. How we have to calculate the true integral? First you have to calculate. So the true integral is equal to true integral is equal to, how we have to calculate? Once you have to say integral 0 to 1 x dx, integral 0 to 1 x dx, integral x is equal to x square by 2. In 0 to 1 you have to apply the limit. First you apply the upper limit. 1 square is divided by 2 minus 0 square is divided by 2. So therefore 1 by 2 is equal to 0.5. So therefore what we have to write? Integral of true value is equal to 0.5. Now we calculated the integral of true value. Now the integral of approximated value, that is the Simpson's, which one we have to take? Integral of approximated value. These are the numerical integrations are approximated values only. So by using the Simpson's is equal to how much we want to calculate. How we have to calculate? By using a Simpson's, which rule they want to use? 1 by third rule. Simpson's 1 by third rule. In the general quadrature principle, n is equal to 2 you have to keep. You will get the Simpson's 1/3 rule. So what is the Simpson's 1/3 rule? Once you have to see, I is equal to h by 3 into y0 first term, yn last term, y0 first term, yn last term, plus 2 into even terms. Even terms means y2 plus y4 plus y6 plus and so on, plus yn minus 2. This is the even terms, plus 4 into, which one we have to take? Odd number of terms you have to take. Y1 plus y3 plus y5 plus y7 plus and so on, plus yn minus 1 you have to take. This is the odd terms you have to consider. Which terms you have to consider? Odd terms you have to consider. Here even number of terms you have to take. How we have to consider? Suppose you have to see our integration limit, lower limit is 0, upper limit is 1. You have to take the step size. Step size h is equal to how much you have to take? They only gave the step size is equal to, this is the step size or interval. Step size is equal to how much? 0.1. Concerning the 0.1, you have to make it. How you have to make the value? X is equal to 0, comma 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, right? So corresponding y value you have to take it as this is the y0, y1, y2, y3, y4, y5, y6, y7, y8, y9, y10. How many values came? Y10 values, up to the 10 values. Y0 to y10 is there. So now these values you have to substitute and you find out the, according to the Simpson's 1/3 rule, that integration you have to calculate. How we have to calculate? Once you have to see here, I approximated value. I approximated value by using a Simpson's 1/3 rule. Which rule it is? By using the Simpson's 1/3 rule. So what is that? Simpson's 1/3 rule is equal to h by 3 into first term in plus last term, first term plus last term, plus 2 into even number of terms. So y2 plus y4 plus y6 plus and so on. So what we have to take? And so on, plus yn minus 2 you have to take, plus 4 into y1 plus y3 plus y1 plus y3 plus y5 plus and so on, plus yn minus 1. Yn minus 1. This is the rule. So that rule only I am giving now. So that rule I have to take. Now you substituted the value. So what is the how much value h? H is equal to 0.13. So y0 is equal to 0. Yn is equal to here yn means y10 last term. So that's why 1. 1 plus 0 plus 2 into y2 is equal to 0.2. Y4 is equal to 0.4 plus y5 6 is equal to 0.6. One more is there, y8 is equal to 0.8. So plus 4 into which one we have to take, y1 0.1, 0.3, 0.5 plus 0.7 plus 0.9 you have to take. 0. How much you have to take? 9 you have to take. Now you add it. 0.1 is divided by 0.1 is divided by 3 into 0 plus 1 is equal to 1. 2 into 0.2 plus 0.4, this is the 1, this is 1, this one 2.0 plus 4 into 0.1 plus 0.3, 0.4, 0.4 plus 0.5, 0.9, 0.9 plus 0. So 0.9, 0.9 plus 9. So what? How much it is? 1.8. 1.8 plus so this 0.7. So you able to get 2.5. You have to get. So 2.5. Clear? So once 2.5, 0.1 is divided by 3. 1 plus 2 into 2, 4 plus. So 2.5 into 4 is equal to 10. How much you are getting? 10 plus 1 is equal to 11 plus 4 is equal to 15. 1.5 is divided by 3. 1.5 is divided by 3 is equal to how much we are getting? 0.5. Similarly, I approximated based on the Simpson's 1/3 rule also. You are getting how much value you are getting? 0.5 only you are getting. But what they are asking? They are asking about the fractional error. They are asking. Fractional error is equal to fractional error is equal to how we have to write. So delta I means delta I true value minus I approximated value. I true value minus I approximated value is divided by I true value. The integral of the true value is equal to 0.5. The integral of the approximated value is equal to 0.5. The integral of the true value is equal to 0.5. 0.5 minus 0.5 is equal to 0. 0 is divided by 0.5 is equal to 0. So therefore, the fractional error is equal to how much we are getting? 0 value we are getting. Once you have to check the answers. So what is our answer is correct? Which option is correct? Once you have to see 10 to the power of minus 4 is wrong. Option B is correct. Option B is equal to 0 only is there. 10 to the power of minus 2 also wrong. 3 into 10 to the power of minus 4 also wrong. Which one is correct? 0 is correct. How many marks you will get? 5 marks in the CSIR examination. How simple is there once you have to see. Don't miss these numerical methods questions. Once you get the numerical questions, you able to do, you will get definitely 5 marks based on the Simpson's 1/3 rule. Maybe Simpson 3/8 rule also will come. Simpson's rules you have to learn. So this is very, very important. Like this we have to calculate. This is the procedure to do, because it is a 5 marks question. Some need to do some little bit procedure, little bit big one is there. Now, if you like really my teaching, if you want to take the course, CSR and GATE physics course is now lively trending. Now you are able to listen. Mathematical methods of physics is completed. Total paper is completed, core and advanced portion in our app. Now the JL also mathematical methods of physics completed. Here mathematical methods of physics completed. We started the classical mechanics. We started the classical mechanics classes. We started. So these classical mechanics now is going on live plus recorded classes. Live plus recorded classical mechanics classes are going on live plus recorded classes. Maybe throughout the 2025 year, I have to teach all the paper. I am keeping the target. All 2025 year I dedicated to the CSIR syllabus only. So that's why you able to listen and practice it. Then it is easy to crack the exam. Clear? Once you download my app, that is Quantum Online Academy app, you download my app, and once you go to the Play Store and download my app, and then you able to see the courses. So those courses will appear like this: CSR and GATE physics, JL physics, DL physics, only physics content only. In CSR and GATE also physics content, not paper one, right? So now mathematical methods of physics, it is completely recorded one only. It is completely recorded one. If you want to take individual papers also available, you want to take it, is this portion is completely available if you want to take. Otherwise classical mechanics, now this course is going on live plus recorded. Live plus recorded, after finishing it will be also recorded only. So live plus recorded every day. So morning 6 a.m. to 8 a.m. 6 a.m. to 8 a.m. there is a class going to take the classical mechanics. Teacher is myself only, right? So in the live class, you able to see 2-3 classes we uploaded in YouTube also. You able to see my teaching style. If you really like, if really understandable, you have to take this course, is very useful to you. So please, thank you for your listening and supporting to our YouTube channel. Please share and subscribe our YouTube channel to intimate to your friends also. We will meet you tomorrow with one more important advanced mathematical methods of physics question. Thank you. Bye bye. Take care.